Imagine a material so durable, so resilient, that structures built with it thousands of years ago still stand strong today, even surviving the relentless assault of seawater. Now compare that to our modern concrete, which often shows signs of decay in just a few decades. The stark contrast raises a crucial question. How did the ancient Romans do it? What was their secret to building materials that withstand the test of millennia and harsh environments, far better than what we produce today? In this video, we're going to dive deep into the fascinating world of Roman engineering to uncover the materials, techniques, and unique properties that made their concrete so remarkably superior. Prepare to have your understanding of ancient innovation truly redefined. If you're as fascinated by ancient marvels as we are, make sure to hit that subscribe button and the notification bell so you don't miss our next deep dive into history's greatest inventions. Let's start with the fundamental building blocks, the materials. The Romans' primary bonding agent was lime, which they produced by a process called calcination. They would burn limestone at incredibly high temperatures, around 1,000 degrees Celsius, to release carbon dioxide and create what's known as quicklime. This quicklime was then subjected to hydration or slaking by immersing it in water. This causes the blocks to decompose, expand, and give off a strong heat, forming a plastic, putty-like substance, what we call slaked lime. Importantly, Roman builders primarily used non-hydraulic lime, specifically preferring pure rocks like marble or white limestone for this process. But the true game changer, the ingredient that elevates Roman concrete far beyond simple lime mortar, was pozzolana. This wasn't just any sand, it was a unique volcanic sand found in specific regions, particularly around Baiae and Mount Vesuvius. Pozzolana possessed an admirable quality. It could transform non-hydraulic lime into a hydraulic material. What does that mean? It means the mortar could set and harden even in wet environments, including underwater. This remarkable property was due to the high concentration of silicate of alumina within the pozzolana. Beyond pozzolana, Romans used other aggregates like quarry sand and river sand. They also ingeniously incorporated crushed pottery or broken tile fragments, which, like pozzolana, contributed to the mortar's waterproof qualities. Vitruvius, the famed Roman architect, even gave us specific mixing proportions. For instance, 1 part lime to 3 parts quarry sand, or 1 part lime to 2 parts river or sea sand. For works exposed to water, like maritime constructions, they'd use 1 part lime to 2 parts pozzolana. The mixing process itself was a meticulous on-site affair. Mortar was prepared near the building site on a beaten earth area, with sand often formed into a crater to receive the pure lime. Water was added gradually, and the ingredients were thoroughly mixed with a long-handled hoe, often called a rabat in French, which describes the crushing movement used to remove lumps. This process, known as tempering, ensured a perfectly uniform and lump-free mixture. Now let's explore how they built with this material. What we call Roman concrete was actually termed opus cementitium, which referred to a core of rubble bonded together with lime mortar. Here's a crucial distinction from modern concrete. The mortar and the pebbles or stones were mixed directly in the wall as it was being built, rather than being prepared as a pre-mixed compound and then poured into formwork. This wasn't a pour-and-forget operation. Construction proceeded in systematic layers, or sections, often about 1 meter high within temporary wooden formwork. As the materials were put in place, they were trodden and thoroughly tamped. This compression compacted the material and helped rid it of excess moisture, contributing to its strength. If you look closely at the interior of some Roman walls, you can still see the horizontal shuttering lines where these layers were built up. This concrete core was rarely left exposed. It was typically covered with a facing of finely dressed material. Depending on the era and region, you might see opus incertum, which uses irregularly shaped rubble. Opus reticulatum, characterized by small pyramid-shaped stones laid in a net-like pattern, or opus vitatum, consisting of regular courses of small rectangular blocks. These facings weren't just decorative. They were structurally integrated using headers, blocks that extended deep into the concrete core, physically bonding the facing to the main body of the wall. While early Pompeian buildings might have had an earthy and badly prepared internal core, the quality facings were key for integrity and waterproofing. And for water infrastructure, their expertise was unparalleled. For aqueduct channels, basins, and fountains, they specifically used a mortar mixed with broken tile fragments. This material was so effective at waterproofing that it formed a lining called nucleus, and when combined with large ceramic fragments, it created the distinctive opus signum flooring, perfectly suited for constant exposure to water. So, what are the true secrets behind this incredible longevity? It boils down to a few key factors that our modern methods often overlook. First and foremost, it's the pozzolana's hydraulic power. Unlike modern concrete, which relies on a more rapid-setting cement, Roman concrete's lime, when combined with pozzolana, gained the ability to set and harden even when fully submerged in water. This made it uniquely resistant to the erosive and corrosive effects of seawater that cause our concrete to break down over time. The crushed pottery used for waterproofing achieved a similar effect. Secondly, their in-situ mixing and layered application contributed immensely. By mixing the mortar and pebbles directly in the wall as they built it up in sections, the Romans created a very strong and cohesive mass. While not explicitly described as monolithic in the same way we think of poured modern concrete, the thorough bonding ensured a robust internal structure. Finally, their success was built on careful material selection and generations of empirical knowledge. Roman builders weren't just throwing things together. They understood which pure rocks produced the best lime and which aggregates, like specific volcanic sands, delivered the desired properties. Their construction methods, often detailed by writers like Vitruvius, were the result of extensive trials and experiments over centuries, leading to practical and incredibly robust solutions. It's crucial to clarify a common misconception. The Romans did not use cement as we understand it today, an artificial mixture like Portland cement. Their bonding agent was primarily lime-based, powerfully enhanced by the naturally occurring pozzolana. In fact, the French word for concrete, béton, comes from the Latin bitumen, which originally referred to a mixture of mortar and pebbles. So the enduring strength of Roman concrete and its remarkable ability to withstand the harshest conditions wasn't a single secret formula. It was a sophisticated interplay of the innovative use of naturally occurring pozzolanic materials for hydraulic setting, their unique in-situ layering and compaction techniques that resulted in a slow, powerful petrification of the core, and finally, their meticulous material selection combined with generations of empirical knowledge and unparalleled craftsmanship. The astonishing ingenuity of our ancient ancestors, who built machines that rival today's innovations, continues to inspire and challenge modern construction practices. Their enduring architectural masterpieces are not just relics of the past. They are living testaments to human brilliance, constantly reminding us that sometimes the oldest solutions are indeed the best.